but you can. Think it's fun.
Assalamualaikum and hello to Puan Zarina and friend. I'm Nur Syahira binti Harun. My metric number is 14 DKM 20F 2051.
Assalamualaikum and hi, my name is Nurul Anis binti Muhammad Amin. My matrix numbers is 14 DKM 20F 2053.
My name is Siti Noraisha binti Azlan. My metric number is 14 DKM 20F 2043.
All the kings have their queens on the throne. We were pop champagne.
How integration can help us in finding the area under a curve. The area under a curve between 2 points can be found by doing a definite integral between the 2 points. To find the area under the curve, y equal f bracket x between x equal a and x equal b. Integrate y equal f bracket x between the limits of a and b. Areas under the x-axis will come out negative, and areas above the x-axis will be positive. How integration can help us in finding volume revolution. First, rotation about the x-axis. Integration can be used to find the area of a region bounded by a curve whose equation you know. If we want to find the area under the curve, y equal x2 between x equals 0 and x equals 5. For example, we simply integrate x2 with limit 0 and 5. Now imagine that a curve, for example y equal x2 is formed. The volume of the shape that is formed can be found using the formula volume equal integrate BA pi y to the power of 4 dx. Second, rotation about the y-axis. If the body is rotated about the y-axis rather than the x-axis, then we use the formula volume equal integrate BA pi x squared dy.
Baby, now and then I think about me now and who I could have been.
This one is example for area under a curve. Okay, find the total area between the curve y is equal to x cubed and the x-axis between x is equal to -2 and x is equal to 2. Area under the x-axis will come out negative, which is this one. This one is negative. Under x-axis is -2, so come out negative. And then area above the x-axis will be positive. Above x-axis, this one is 2. So like this. Alright. So this one come out negative, so it will go down, and then come out positive, it will go up. And then shaded, mark, and then shaded. This one is for area under the axis with negative, and this one is area under the x-axis positive. If we simplify integrate x cubed between -2 and 2, we will get x to the power of 4 over by 4 close bracket 2 -2. Okay, why we put 2 not -2? Because 2 is bigger than 2, because 2 is bigger than -2. Okay, how we will get x4? -4. Okay, x4 -4 we will get from x to the power of 3 plus 1 over by 3 plus 1. So we'll get x to the power of 4 over by 4. So the working is like this. X to the power of 4 over by 4 to -2. So we put 2 into x, which is 2 to the power of 4 over 4. Then minus -2 into x, which is -2 to the power of 4 over by 4. Then when we simplify this one, we will get 4 minus by 4. Then the answer is 0. Okay, so instead we have to split the graph up and do 2 separate integrals. Okay, which is integrate 0 x cubed dx is equal to x to the power of 4 over by 4 close bracket 2 0. why we put 2 up and 0 down? Because 2 and 0, because 2 is bigger than 0. That's why we put 2 up and 0 down. Okay, then we just put 2 into x, which is 2 to the power of 4 divided by 4 minus by, put it 0 into x, 0 to the power of 4 divided by 4. Then we simplify, we will get this one 4, and then this one we will get 0. 4 minus 0, we will get 4. Okay, next for integration 0 negative 2 x cubed dx. Okay, x to the power of 4 over by 4 integrate 0 negative 2. Okay, we put 0 up, negative 2 down, because 0 is bigger than negative 2. That's why we put 0 up and negative 2 down. And then put it 0 into x, which is 0 negative to the power of 4 over 4 minus by, put it in negative 2 into x, which is negative 2 to the power of 4 divided by 4. So this one simplify, we get 0, and then minus simplify, we get 4, and then the answer is negative 4. So the area is 4. We won't take negative, we just take positive. Okay, don't take negative 4, but we take positive 4. Then the last one, total area. Total area 4 plus 4, we will get 8 units square. So this one answer for total area under a curve. That's all from me. Thank you.
So this is the example for volume revolution. So the question for this example is the graph of y equals x the power of 4 between x equals 1 and x equals 3 is rotated completely around the x-axis. Find the volume generated. So this is the graph. So this is the y-axis, this is the x-axis, and this is the whole graph for the y equals x over the power of 4. So we have to find the volume generated. So we'll start with this first. Volume integral 3 1 pi x the power of 4 dx, and then we will put brackets, this pi x5 over 5, and then we will close the brackets, and we'll put this square 3, and then we'll put, and then will be 243 x, and then you will divide it with 5. This will be minus with pi over 5, and the answer after you finish this calculation will be 48.4 pi. So the volume generated by the graph after the graph is being rotated completely around the x-axis, this graph, which is this one, will be, the answer will be 48.4 pi.